So today's lesson is going to be kind of nice in that it ties together a bunch of stuff that we've been talking about. I've been alluding to these rules. I've been showing you bits and pieces. Today, we're going to put it all together. So a lot of what we're going to learn today is actually going to help you in going back and checking some of the work that you did in the past. So please give me your full attention and let's go over the laws of logarithms. The nice thing is, again, that with each of these, they're all related to stuff you've already been doing. And some of it having the connections is going to give you multiple ways to solve a lot of these problems. Sometimes you'll get stuck on previous problems. And now that you have more tools, you'll be able to go back and fix those as well. All of the rules that I'm going to show you here are linked to the rules of exponents that you already learned. So the product rule right here says that if I have two things multiplied together inside a log, I can split those into two separate logs that are added together. This log rule works because of the way exponents function. If I have x to the a plus x to the b, two different bases added together, when I add, or sorry, I am going the wrong way there. X to the a times x to the b. If I multiply the bases, I can then add the exponents, x to the a plus b. This product rule is directly linked to the log product rule. It's just coming at it from a different perspective. Here we see, oh, the exponents are added together because the bases were multiplied. Here we see if things inside are multiplied, it means when I evaluate those, I could add log base 6 of 3 plus log base 6 of x. And again, the whole purpose is think of this as your exponent, right? That's what it's saying. Something to a power makes 3 to the x. So again, you don't have to directly make that connection, but the idea is that this product rule of exponents is where this product rule of logs comes from. Both of them saying that multiplication in one form can become addition in another form, or addition in one form can become multiplication in another form. Same thing with the quotient rule. If I have division inside my log, it can become subtraction between the two logs. That is, again, because x to the a divided by x to the b is x to the a minus b. Again, if I was looking at log base b of m, I get an answer. It's the exponent of b. So if I have the exponent here minus the exponent here, that's the same as doing the division of the original pieces. This divided by this becomes x to the a minus b. Division inside a log becomes subtraction outside of a log. And the power rule. If I have log base b of m to the n, a power inside my log, I can take that power and bring it out in front and make it multiplication. Because if I have x raised to the a raised to the b, this would be x to the a times b. Exponent raised to a power, I multiply those two exponents. So if I have a power inside my log, it's the same as multiplying by that out in front of my log. There's going to be multiple ways to use these. You could go in different orders as long as you're careful and following like grouping rules and all of that good stuff. Everything will work out quite nicely. I'm going to have you add two other rules here that aren't technically log rules, but things that we're using a bunch with logs. The first one is just the transformation between exponents and logs that we've already been looking at. If I have log base b of a, well, I've been doing of x equals a. If I have something written like this, I can rewrite it as an exponent by bringing the b down. A becomes my exponent. X becomes what I'm equal to. B to the a equals x. Does that make sense? We've been using this a lot. We'll be using it a lot more. Not necessarily today, but in the future. So I'm just having you put it with the other log rule, so you have that. And then the other one that we're actually going to use on Thursday, but I'm going to give it to you now so you have it, is the change of base formula. This one actually has a name, change of base formula. Every rule that we were looking at, the base stayed the same. The only way that you can change the base of a log is with this formula, and it lets me take any log base that I have, so log base b of a, and rewrite this with a new base, log base c of a, so long as I then divide that by log base c of the old base b. This is the only way you can change the base of a log. And we'll be using that a lot on Thursday. Does anyone have any questions about the log rules so far? All right, so everybody's full attention. Go ahead and put iPads, phones, e-readers, all that good stuff. Put it all away, and let's knock out a couple examples, and then you guys can try the homework. I'm going to do a few of them slowly, and then I'm going to pick up speed in the hope that after you start figuring out what's going on, these become easier and easier. We can do them very quickly, even skipping some steps. So number one, I see multiplication, 14 times x. Multiplication means the product rule. So I'm going to split these up, log base 3 of 14 plus log base 3 of x. I'm done, because neither of those simplify. All I did was take it, split it apart. Multiplication inside becomes addition outside. The next one, same thing's going to happen. Natural log of 12 plus natural log of x to the 5th. Now, I should have asked you before I even split it. Does that 5 exponent apply to the 12 and the x, or just the x? Just the x, which is why I split it like this first. Once I get it split so that the only thing that's inside this natural log is the x, and the x is raised to the 5th power, now I can use the power rule. I can bring that 5 out in front and make it the natural log of 12. It still doesn't have a 5, but 5 times the natural log of x. 5 times the natural log of x. Number 3, I see division. That becomes subtraction. Log base 3 of 3 minus log base 3 of 5. Again, all the bases have the same log as the starting one. With this, though, with this one of these simplifies. The first one, log base 3 of 3. 3 to what power makes 3? 3 to the 1st power. So 1 minus log base 3 of 5. That would be my answer. In fact, you guys, this is going to happen so much while we're doing these that you might want to write this down as a rule as well. Somewhere here, log base a of a. If these match, the base of what's inside is the same, it's just 1. Yes. Because of the division. The division rule here, or the quotient rule, says that if I have division inside the log, I can split it into one log minus the other. And again, the top one is first. The second one, the bottom one, is second. Another way of thinking about this, is everybody clear that if I have a fraction and I'm talking about exponents, things on the top of the fraction have the positive exponent, things on the bottom have a negative exponent. And so if I bring that negative out in front, it makes it subtraction. So number 4, natural log of e to the 5th minus natural log of 7, right? The first one was on the top. Second one was on the bottom. It's the subtraction one. Notice how the natural log here, this is positive. Positive natural log of e to the fifth, it was on the top, minus the natural log of 7. Natural log is log base e. You have two options for reducing this one. The long way would be to say, oh, bring that 5 out in front. 5 natural log of e. The natural log of e is just 1. 5 times 1 is 5 minus the natural log of 7. Or right here, you could have seen, oh, natural log of e to the fifth power. E to what power makes e to the fifth power? 5. So you don't have to do those middle steps as long as you understand the reducing that we've done last week. So 5 minus the natural log of 7 would be the answer there. So far, so good. If you understood the rules, everything so far is hopefully not bad. Number 5, though, is where we start to make mistakes. Number 5, I'm going to show you two ways. First way, log base 4 of 16 minus log base 4 of 3a, right? Because it's a division, that becomes subtraction. Log base 4 of 16, 4 to what power makes 16? 2, right? Not 4, it is 4 times 4, but I want powers, which means 4 squared. So this is going to be a 2. But right here, I can split this. This is multiplication, right? So it becomes addition. But right now, that whole thing is being subtracted. So if I want to split this, I'm going to make it log base 4 of 3 plus log base 4 of a, but it has to be in parentheses with the negative out in front because I'm subtracting the whole thing. That didn't close the parenthesis. There we go. Does everybody see what's happening there? That subtraction still has to apply to both of those logs. I can distribute that negative in 2 minus log base 4 of 3 minus log base 4 of a. So I could distribute the negative in, or look back at the original one. Look at what was on the top. Log base 4 of 16 was on the top. That should be a positive one because it's got a positive exponent. The 2 on the bottom, you could think of those as having negative exponents. That's why they're on the bottom. They're both on the bottom. They both have negatives when I'm done. Does that make sense to everybody? Anything on the top should be a positive log. Anything on the bottom should be a negative log when I'm finished. Does that make sense? If you understand that principle, you can skip a lot of that middle work and jump straight to which ones are positive and which ones are negative. So with that in mind, number 6, do I have any division here? It's all multiplied together, so they should all be positives. Let's jump straight to just breaking them all apart. Natural log of e plus the natural log of a cubed plus the natural log of b. How do I write a square root as an exponent? Fraction, specifically 1/2, right? 1 over 2. So b to the 1/2. Then any exponents, bring them out in front of that log, not another log, the one that they were inside. So natural log of e, there's no exponents here. This literally just becomes 1, right? It's asking log base e of e. This is just 1 plus the 3 comes out in front, 3 natural log of a, 1/2 comes out in front, 1/2 natural log of b. That's my answer. We okay there? So just real fast, last few examples. Number 7, log base 3 of 27. Can I do it all kind of in one step? Can I bring the exponent out? Is everybody good with this being 4 log base 3 of x plus log base 3 of y plus 3 log base 3 of z? Does everybody see what I did there? I brought for each piece, put the exponent out in front of its log, and then log base 3 of that particular variable or constant. So I'm skipping steps here. You don't need to skip steps, especially if it confuses you. But if you're good with what's going on, you're welcome to do that. Which of these can I simplify? Log base 3 of 27. Everybody good? 3 to the third power makes 27. So 3 plus 4 log base 3 of x plus log base 3 of y plus 3 log base 3 of z. And then I just add these 3 and 4 together. Please don't. Please don't. Right? The 4 is times a log. Does that make sense to everybody? 4 log base 3 of x. I cannot combine that 3 and the 4. I have so many students that try. You want to add, you see that 3 plus 4, you want to do it. But you cannot add if one of them is involved with multiplication, right? The multiplication would have to happen first. Or they have to be the same log. If I have 4 log of x plus 5 log of x, I could combine those because they're like terms. But not this. This is done. I cannot simplify this anymore. So number 8. Number 8, log base 5 of 25 plus log base 5 of x cubed. Log base 5 of 25 is 2. Log base 5 of x cubed, bring that 3 out in front. Log base 5 of x. Now on the homework, there's some that don't have multiplication. If there's no multiplication inside the log, you cannot split it into 2 logs of a log plus a log. Even though all of these were doing that, if there's no multiplication, you can't have that step. You cannot break things apart with the product rule if there's no product property, no product actually being evaluated. Last one of these. Is everybody good with it being natural log of e squared plus, actually, let's go ahead and bring that 1/2 out in front. 1/2 natural log of x. And then the natural log of y to the 4th, or even bring that 4 out in front. 4 natural log of y. Is this a plus or a minus? Minus. It was on the bottom of the fraction, so it's minus. Almost done. Natural log of e squared is just going to be 2, 1/2 natural log of x minus 4 natural log of y. So I had been intending to assign all the problems for homework, but I know we're going to be a little pressed for time, and I'd love for some of you to get a little bit of extra credit. So you should do all of the problems, but I'm only assigning the even ones. All right. I would start right now with numbers 2 through 14. 2 through 14 on the homework. There is an extra page in your note or in your homework packet. Don't do the activity page, okay? Flip over to the worksheet page. The activity page lets you discover the laws of logs based off of exponents that I was just teaching you. You don't need to do those right now. Let's just focus on the homework. I'm going to give you 5 minutes. 5 minutes to get as many of those done as you can. Okay, so back to the notes. Second page. We're going to talk now about going backwards. The exact same rules, exact same process, just go backwards. So in order for this to work, I'm going to do a couple and then start calling on you guys now that you've kind of practiced it. Going one way, I think most of us can figure out what to do going the other direction. So like number 10, I see a log minus a log. I can bring that together into a single log of the first one divided by the second. Remember, positive ones go on top, negative ones go on the bottom. So natural log of 18 divided by 3. What is 18 divided by 3? 6. So this is just the natural log of 6. Now, this is where having a calculator can get you in trouble. If you do natural log of 18 on your calculator, you get like 2.89037. And then if you do the natural log of 3 on your calculator, you get like 1.0986. If I subtract those and get some nasty decimal, it's technically the same nasty decimal as the natural log of 6. But I'm not going to realize that. Does that make sense to everybody? This natural log of 6 is the exact answer. That's what I want to see. I don't want the natural log of 6, which is like, what is that? Natural log of 6 is 1.791759. Goes on forever. You get the same answer if you do the natural log of 18 minus the natural log of 3. But that's not what I want. I want the exact simplified one. This is so much nicer than that decimal. Next one. 3. A number out in front becomes an exponent. Log of x to the 3rd power plus log of 9. Addition between two logs becomes multiplication inside. I'm actually going to switch them, make it 9x cubed, because that's the way we're used to seeing it. Is everybody clear that this only works if the logs match? They have the same bases. If I have a log base 2 plus a log base 3, I'm stuck. I can't combine those. They have to have the same base. All right, so then number 12. This 5 is going to come up, log of a to the 5th power, minus, actually, let me show you, no, I'll keep with the standard ones. Minus, bring the 2 up, log of 8 to the 2nd power. The minus then means division. Log base 10, we don't see that, but it's base 10 of a to the 5th power divided by 8 squared. If you have a number to a power and it would evaluate to something less than 1,000, go ahead and like multiply it out. So this one, log base 10 of a to the 5th power over 64. 8 times 8 would be 64. Now, one other quick note. I could have done this another way. I could have taken, instead of the 2, I could have taken a -2 and made it my exponent. So I would have had log of a to the 5th power plus log of 8 to the -2nd power. Then I'd put them together. Log of a to the 5th times 8 to the -2. But what do I do with a negative exponent? Becomes a reciprocal, goes down to the bottom of my fraction. Log of a to the 5th over 8 squared. Same thing I had before. Again, that's why there's that minus there. It's representing a negative exponent, which means the denominator of the fraction when you put it together. Let's have you guys do a couple of these, and then I'll give you some time to work on the homework. Number 13. What do I do with this 3 right here? Let's get someone that's here today. Nope. Oh, not here anymore. And not here. Nathan S. What do I do with that 3? On which number? On the 2. Does that make sense? The 4 is just the base of the log. They're all log base 4s. Log base 4 of 2 to the 3rd power. And then I need to do something with this 2. Davian, what do I do with that 2? Yep, 2 to the, or 1/2 to the 2nd power. So plus log base 4 of 1/2 squared. And same thing, this 4. Ednan, where's that 4 going? Yep, log base 4 of y to the 4th. Now, I need to put them all together. I'm going to make one big log base 4. I have 2 cubed, 1/2 squared, y to the 4th. What's going on between each of those? Am I adding, subtracting, multiplying, dividing? Caitlin, what do you think? So they were adding. What does it become when I put them together? It becomes multiplying. Does that make sense to everybody? They're all positive. They're all going to be on the top. It's all multiplication. And I can simplify this. I could do literally 2 times 2 times 2 times 1/2 times 1/2. Or I could say, okay, it's 8 times 1/4. Or I could write it as like 2 times 2 times 2 over 2 times 2. However I choose to do this, is everybody clear that it's going to reduce? 8 divided by 4 is just going to be 2y to the 4th. So log base 4 of 2y to the 4th. And then last one, and then I'll give you guys almost 10 minutes here to try it. I'm seeing that this one and this one are both positive, but the third one is negative. The fact that the next set, you're good. The next set here, 2 positives, 1 negative. Did you find them? Yeah. Okay. So here, this is going to be log of 6 times 2 to the 3rd, right? Those are both positive. They're going to go on the top. But this one is negative. It's going to be a 2 squared on the bottom. Does everybody see where that came from? So last bit then, I can reduce this. I can do 6 times 2 times 2 times 2 divided by 2 times 2. Or I could start simplifying. I've got 2 2's on the bottom, 3 2's on the top. This is really just going to end up being log base 10 of 12, 6 times 2. But wait, we could even have done this here. Does everyone see that I have 3 log 2's minus 2 log 2's? What's 3 log 2 minus 2 log 2? 1 log 2. That's what I'm doing here. I can subtract these. It's the same as reducing the fraction. Both of them will get you the same answer. Either way, I should get log of 12. All right, take the next 8 minutes or so to work on the homework and to ask any questions you might have. I know I didn't hit the last couple examples. Oh, I do need to show you one thing. Sorry. Everybody look at 18. If you have a number, sorry, everybody's attention just real fast. If you have a number that doesn't have a log and you want to combine it, you're going to work backwards. These are all natural logs. So I need this to be a natural log. Write it as log of the base of the same thing. So this one's natural log. What's the base of natural log? E. So this is going to be the natural log of E cubed. Does everyone understand that the natural log of E cubed would reduce to 3? So I'm rewriting it, I'm unreducing it, and then I'm doing the rest of it like we already did. So you'd combine the natural log of E to the 3rd minus natural log of A minus 2 natural log of B cubed. This would become the natural log of E cubed on the top over an A, and then the 2 times the 3, that was already the exponent, would make it B to the 6th. Negative ones go on the bottom, positive ones go on the top. Okay, now for reals, you can go ahead and work on the homework there. We're doing 2 through 30 evens. I would recommend you do all of them, get a couple points of extra credit.